So number one question that comes to our mind is what exactly is a function? Like when you talk about the function, like the general notation that we use y equals to f of x, sometimes it is referred as x is mapped on f such that they will say give a function here x squared minus 3x or something like that. So as far as the notations are concerned, these are some of the basic things, the way you kind of look at. Now, I'll just straight away start with one of the example. Let's say f of x has been given as x squared minus 3x. Now, our major objective will be to first understand what is, let's say, the basic concept of functions, basic functions. Then you will have, second will be, let's say, understanding the domain and range, domain and range. And the third is going to be, will be understanding how to basically transform the functions, transform functions. And fourth will be something called as composite function. So the objective of this lesson is to understand these critical things about the functions. We'll try to keep it in as concise way as possible. Now, first thing is that when you talk about basics of functions, like as you can see the notation, like you need to understand certain key terms, like for example, mapping. Like when you say mapping, second thing is that when you say when is a given relation function, so relation and difference between relation and a function. So this difference between relation and a function. So mapping is basically like, for example, if you have, let's say these are the x values and these are the y values. Now, for example, let's say if I have 1, 2, 2, 5, 3, let's say 7, 5, 8, or something like that. So when you say 1, 2, 3, and 5, these are the x values. They are mapped with 2, 5, 7, and 8. So 1 is mapped with 2, 2 is mapped with 5, 3 is mapped with 7, and 5 is mapped with 8. And this is referred as one-to-one mapping. This is referred as one-to-one mapping. Now, when you say one-to-one mapping, it simply means that for one x value, you have one y value. So one x has one y value. This is the meaning of one-to-one function. Sometimes you might say that, okay, now let's say this is 5, 8, and then let's say I say, okay, there's, let's say 1, 7 as well. So now if 1, 2, so let's say 1 to 2, let's say I'll just rewrite it. So 1, 2, 3, and 5, 2, 5, 7, and 8. So 1 is mapped with 2, this is done. 2 is mapped with 5, this is done. 3 is mapped with 7, this is done. 5 is mapped with 8, this is done. But once again, 1 is being mapped with 7. So this is something is now one to many mapping. Many mapping. Now, there are like other types of mappings as well, but like when you just see like, okay, one x value has many y values, one to many. Many x has one y value, it is called many to one, something like this. Let's say 1, 2, if it is mapped with like 3, 5, 7, 6. Let's say many x values, when they're mapped against the same y value, something like that, it is called as many to one. So now, in general, when you talk about the mapping, it is not that important part in the standard or higher level syllabus. But what actually we need to understand is something called as a test, which is vertical line test. Now, when you talk about the function and their general nature, what is important is like, if you look at if you visualize the graph of it, like if you look at the general graphical presentation, let's say I have a graph simply here. Now, if you draw a vertical line and you can see that the graph cuts at more than a point, if the vertical line cuts the graph at more than a point, then that particular relation is not going to be a function. Because generally function is used to model the real life phenomena. Like, for example, let's say I can't say that at one point of time, let's say this is the time, is 3, and I have like 3 million cases and minus 3 million cases. So that's where it violates the rule of like in a real life terms, where one x value should have only one y value. So these kind of things will have a function, like will be a function. Like for example, here, if you draw a vertical line, it cuts the graph at only one point. So these functions, these graphs or these relations you see is a function. So if I look at the bigger picture, so you have the bigger picture is like you can set up the relation, but only some of them will be function, and that too, whichever fulfill the vertical line test. All right, so when you talk about the domain, like in the mapping, generally, whatever the x values you get, like for example, 1, 2, 3, and if you're mapping with like 7, 5, and 8, so this is referred as input, and this is your output. So whatever is the input, if I have like, for example, let's say this is the input, and the output is 7, 5, and 8. So domain here will be 1, 2, and 3. That's your domain. And range will be the y values, which is 7, 5, and 8. So generally, when you look at a function as a machine, this is the function. So whatever the input that you get, the function, meaningful input that the function can take is called as domain. And whatever is the output that you get is called as range. So what we'll be looking next up is that how to graphically read the domain and range. And second is how to graphically or how to algebraically do the domain of the given function, at least like, on the basic level. So when you talk about the domain, let's say, for example, if I have given a graph, now I'll just actually show that animation here. So now when you look at the given graph here, so you can see that the graph is basically from, it extends both the sides all the way to infinity. Now, whatever the x values you can see that the graph takes is called as the domain. So the red lines that you can see along the x-axis, that's your domain. And along the y-axis, the purple lines that you can see, that's your range. So now for me, if I look at in simple, like, like lame term here, the domain looks like to be this side, which is x less than -1. And if I look at this side is x greater than or equals to +1. That's your domain. And this, since this extends all the way to infinity, that's your domain. Well, if you look at the range is along the y-axis. Now range will be here, the y values are above this line. So y can take these, the y values that are existing here are y above or equals to +2. So that's your domain and range for this specific graph. So when you have to find out the derivative of this, it is really important that you consider this filled gaps, like, filled and not filled gaps. So when you look at the domain here, so corresponding domain would be x greater than -1. So that's x is greater than or equals to -1. And range is below 3. So y is less than or equals to 3. That's correct. Now, when you look at this one, the domain is that when you write down, you have to say that x is not included at -1. It is greater than 1 or -1, and it is equals to 5. It is included as 5. So this is the domain. And range for this will be same way, y between 1 and 3. 1 not included, 3 being included. Now, as far as C is concerned, like this is a case where, like, you can see there is a vertical asymptote. This is referred as vertical asymptote. And now at that point, your function is undefined. So if you input in x equals to 2, you'll get either the y values, the error, or undefined. So when you write in the domain, now the rest of the part, you can see the graph exists. Here it exists, and here it exists. At only x equals to 2, it doesn't exist. So you say that domain is x belongs to real numbers, and x should not be 2. And range will be y belongs to real numbers. Similarly, y should not be -1. So x belongs to real numbers, x should not be 2, y belongs to real numbers, and y should not be -1. Now, as far as the D part is concerned, now in D part, domain, you can see that it extends both the sides. So domain is all real numbers. So x belongs to all real, and y will be between 0 and 2, which is the range. So range is y between 0 and 2. So 2 is inclusive, but 0 is not included. And the third one is here domain is all real numbers. Range is y is greater than or equals to -1. This one domain is x belongs to real numbers. Range will be y less than or equals to 614. So that's how you predict the domain and range for this particular question. So for this one, the domain is basically x greater than or equals to -4, as we can see from here onwards. And the range is y above -3. And for this one, the domain is all real numbers. And range is only, you can see that this is not coming below y equals to -2. So it'll be above -2. So range will be y greater than or not equals to y. It will be straight away greater than -2 because the graph doesn't exist here, unlike the previous one. So you'll have to say y is above -2. Here, the domain is x belongs to real numbers. X should not be plus or -2. And the range is basically y greater than 0 or y less than or equals to -1. Because you can see that these y values, the y values that are taken are here and y below -1. So that's the domain and range for this particular specific kind of question.